Hello, we're from Group 1 and we'd like to discuss our project on linear programming titled Maximization of Profits in Mass Sales. Here are our group members. Firstly, starting with me, Akbida Farhan Fausta.
And me, Arkan Labib Abinaya.
Hello, my name is Ardianino Maindaru.
My name is Ashifa Indira Fauzia.
My name is Aulia Kezia.
And my name is Aurelia Zepanya Salahi.
Table of contents. First is definitions. Next, project background, problem statement, project objective, project methodology, data and analysis, result and discussion, and the last is conclusions. The first, definitions. Linear programming are mathematical modeling technique in which a linear function is maximized or minimized when subject to various constraints. This technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, and to a lesser extent in the social and physical sciences.
Next is project background. During the pandemic, the demand for masks rose drastically so that many health companies committed to produce masks that were suitable for use to maintain the health of the consumer while gaining profits. And it is best to use linear programming as a method to find the most profitable mask to produce. Next, please. Next is problem statement. M Company is a startup mask company producing health masks. Currently, the company has chosen two types of masks to be produced, namely KF94 and duckbill. However, as a startup company, they have limited stocks of materials. They have to choose the amount of mass produced between each type of mask to maximize their profits.
Next, the project objective. The business aimed to take the opportunity provided by the COVID-19 by selling products with the highest profit whilst minimizing the use of the limited materials. By the end of this project, we aim to determine the best amount of masks between the two types to maximize the profits of the business. So the materials that needed to produce masks is fabric and rubber strap.
As stated before, the materials that is needed in the mass production process are fabric and rubber strap. For the fabric, it is required as much as 252 times 8 centimeters for the KF94 mask and 240 times 11 centimeters for the duckbill mask. For the rubber straps, it is required as much as 100 centimeters for the KF94 mask and 80 centimeters for the duckbill mask.
Sales price. Price of each type of mask per dozen. From a business standpoint, the company aims to gain the most profit by selling the mask with the highest price. As you can see from the graphs on the screen, the KF94 have the price 7,000 rupiah and the duckbill have the price 6,000 rupiah. Project methodology. Phase 1, data collection. In this project, we combine data that we create ourselves with the data from the internet. Phase 2, data analysis. LP model analysis. First, objective function. Second, constraints. And the third one is formulation of LP model graph.
Next is data and analysis. So we've obtained the data and the next step is to plot it into a graph as we did here. And here we got the data from the internet we found on the internet the average size of a KF94 mask as 252 times 8 centimeters, and the average size of a duckbill mask being 240 times 11 centimeters. And our company has a stock of fabric with a length of 30,500 centimeters And we also have our stock of rubber straps is 1,075 centimeters. And from this data, we'll then plot it into a model graph as seen here. Again, from this data, we are able to make two lines. The first one being line A, and it is 2016x plus 2641y, and it has to be less than our stock, which means it has to be less than 30,500. And the next line being 100x plus 80y, and it has to be less than 1,075. And from these two lines, you are able to determine 3 points, that being point A, point B, and point C. Point A here is the intersect between two lines, which is 3.88, 8.59. And point B here is the intersect of the with the y axis, and that is 0,11.54. And point C here is the intersect with the x-axis, and that is 10.87, 0. And from this data, we are able to come up to a conclusion, which is, firstly, I'd like to state here that because it is impossible to create a point of a mass or half of a mass, so we've decided to round our numbers to the nearest integer. And here is seen our renewed data. And our mistake here in point C is supposed to be 10, 0. And from that, we can conclude that point C with 10, 0 has the highest profit of 70,000 rupiahs.
So there's the conclusion in our discussions. Our objective is maximum profit. To reach the highest profit, the company needs to produce 10 dozens of KF94 masks and produce 0 dozens of duck bill masks, which in total we sell for 70,000 rupiahs. I think this enough for our group to presentation. Thank you very much for your attentions. Goodbye.
Thank you.
Thank you.
Thank you.
You.